Hello friends, today we are going to discuss about something called oscillations. Now what are oscillations? Now before going to actual oscillations, we need to understand the types of motion. We have so far seen something called translational motion, then rotational motion, then we also discussed circular motion in the past, right? Let us try to figure out what are the differences between these different types of motion. Now, what is translational motion? Now, translational motion is when the position of particle it changes. Okay, the particle is over here at position A, and now it changes to that position changes to point B here. Right. So initially it was here, now it is here. So there is translational motion. Okay, and when do we say that the particle or a body is in a state of motion? When the position of that body changes with respect to its immediate surroundings, then we say that the body is in motion. So now here my coordinates are changing, so we say that this body is in motion. Okay, now the second one would be rotational motion. Rotational motion. Now here the coordinates of the body as a whole, they do not change. Okay, but then there is still some motion. Now example would be fan, ceiling fan. The ceiling fan remains over there, okay, but then it is still in motion because there is some motion about an axis of rotation, isn't it? So even though the fan is not changing its position, we say that it is in rotational motion. But at the same time, if we see the motion of tip of blade of fan, okay, this is that ceiling fan, and okay, and we have these blades here, okay, and this tip of blade, if you look from below, okay, that blade would move something like this here in this direction. Tip of blade would move like that. Then midpoint of blade would move something like that. Correct. So here the fan as a whole, it is not moving, but then the points on the blade, they are moving. Correct. And they are moving about a fixed point here, center, and then that motion of tip of blade of fan, we call it circular motion or motion in a circle, which is a special case of translational motion, because at every point of time the coordinates of the tip of blade are changing, okay, but then center of the fan remains same, okay, it doesn't change its coordinates, okay. So we call it special case of translational motion, okay. Then all right, but then what is the difference between this motion and this motion? See, the tip of blade was at point A, let us say. Now after certain time it came to point A again, correct, and then again it continues its motion and it comes to point A. If the fan is moving with constant speed, then this particle at the tip of blade, it would be performing uniform circular motion. Okay, so we should understand here that this circular motion of tip of blade of that fan, okay, it is a periodic motion. Now why do we call it periodic? Because it repeats itself after a certain time. Maybe that time interval may be regular, or it can be irregular, depending on whether whether it is uniform circular motion or non-uniform circular motion. If the fan is running for quite some time, okay, it's running maybe I consider that motion after a minute, let us say, and then after that I monitor the motion, then the motion may be uniform circular motion. But then the fan is at rest and I switch it on, then what happens? It starts from rest, the speed goes on increasing, and then after some time it attains the maximum speed of rotation. Okay, so over there the speed, right from the beginning, if I consider, okay, the speed will not be uniform, okay, but anyway it is going to be a periodic motion. Okay, what about any other type of motion that we can think of? I have translational here, I have rotational here. I might think of maybe the motion of a pendulum here. This is a fixed support, and I have this string. Now this string is inextensible. It is massless, or a string with negligible mass. Okay, and I also assume that there is no friction at the rigid support, and then I have this bob. Okay, heavy bob. Okay, now here there are different things, different conditions that I am imposing. Now first of all, I am saying that this is a rigid support. All right, that is fair. Okay, then I say this is an inelastic and inextensible string. Okay, inelastic, inextensible string. Okay, and then it is also massless. Now one thing is there, something that you can see. For example, you see this marker. Can you say that this is massless? No, its mass may be small, but then it will still have some mass. Okay, but still I am saying massless string here. Then string is inextensible. Can something be some string be really inextensible? It is highly impossible. Okay, it will never be inextensible. There will be some extension produced under the action of some load, right? So this is one assumption, this is one assumption, and then I say it is inelastic. Can some string be perfectly inelastic? No, again, correct. So all these things, they are practically not possible, but then here we are assuming those things to exist. Now when I say massless, what do I mean by massless? Mass of the string is negligible compared to mass of this bob. Okay, then I can say that the string is massless, inextensible. Now for the mass of this bob is a small bob. Okay, and compared to mass of this bob, and with the bob attached to the string, and then the string being suspended from this rigid support, if the extension in the string, if it is negligible, then my this point is also satisfied. So this is satisfied, this is satisfied. And what about inelastic? Again, if it is not getting elongated, okay, if it is not extending in length, correct, there's no question of the length being restored, isn't it? So again, this part is also satisfied. So we lay down certain conditions which may sound to be impossible, but then in physics we need to have certain ground level, and so that we can compare the results. Okay, so I was talking about this pendulum. This is called simple pendulum, heavy bob suspended from a rigid support by means of a massless, inextensible and inelastic string. Okay, now when do I call it a simple pendulum? Okay, suppose I give it some displacement in this direction. Maybe I displace it through certain distance here. Okay, I displace it over here. I'm holding it, and now what I do, I just leave it. What do you expect to happen? Because of its own weight and this string, okay, there will be some tension in the string, right? When this bob of mass m, it is suspended by means of the string from this rigid support, there will be weight of this bob acting vertically downwards. Now what happens when this bob is displaced? Again the weight is going to act. Okay, but now the weight of bob will tend to pull it back to the mean position. Correct? It is quite obvious, isn't it? So this bob is going to come back to the mean position. Now at the mean position, is there anything that could stop the bob there? No, there is nothing there. So what happens to the bob? It moves further. Okay, it moves further and moves to exactly the same distance as it was moved to the right. It would move that much distance to the left. Okay, and what would happen then? When it reaches that distance, at that point again it will stop momentarily and it will come back to the mean position, and then that will go on. Okay, it will go on. Now here I am also ignoring the air resistance. So when the bob of the simple pendulum is set in motion, I am ignoring the air resistance. That air resistance is going to be so small that it can be ignored. Okay, practically it will not be something that we can ignore, but then for simplicity, for setting some standards, we have to do that, and we will do that. Now here, motion of this simple pendulum. Okay, what happens? I just displace it towards right, and then it came back to the mean position. It moved further, it went to your left. Again, after some maximum displacement, it started coming back, came to the mean position and moved further, and so on. So the oscillations, this motion is called oscillatory motion, or we can call this as vibration kind of a motion. Now when you say vibration, what are vibration? Vibration is something like this, right? Okay, the branch of a tree, because of wind, okay, what happens? The branch of tree, it kind of moves like this, it vibrates, isn't it? Motion of this pendulum is also something similar to that. It moves back and forth, okay, back and forth, or it moves to and fro here. Okay. This motion, which is periodic in nature, it is called oscillation, right? And that is the title of this new chapter that we are going to start. It is oscillations. So in short, oscillatory motion is it is a periodic motion, number one, but then it is to and fro motion. In case of circular motion, what happens? It is periodic motion. Okay, but is it to and fro? No. Suppose this fan is moving anti-clockwise like this, it keeps on moving anti-clockwise. Okay, it doesn't move anti-clockwise and then clockwise and anti-clockwise and then clockwise. No. If you think of motion of that hand fan, okay, over there it is to and fro and back and forth. You can say that motion is oscillatory motion, but then not motion of a ceiling fan, right? So both the motions are periodic, but then when we talk about oscillation, it is to and fro or back and forth periodic motion. Okay, in the next video we are going to talk in detail about something called simple harmonic motion, and then equations of simple harmonic motion, differential equation of simple harmonic motion, and so on. Thank you so much.